Hi, everybody. We'll wait a few minutes and then we'll start this show. We want to have Firefly's AI on this session, Matt.
I'll leave that up to you. I personally never used it.
I saw somebody put it in there. I don't think this is going to be recorded anyway.
Right.
So we'll wait maybe 2 minutes past the hour and then we'll start, Matt.
Yeah, it sounds good to me.
I think right now we are 2 minutes past the hour. So, hi, everybody. Thank you for joining us on this seventh Building Energy Codes Working Group Symposium. And we are going to be talking about next generation building energy codes. So most of you know me, but some of you probably don't. My name is Melis Stilianu. I work at Natural Resources Canada, and I'm the co-chair of the working group as well as the chair of the Energy in Buildings and Communities Technology Collaboration Program, EXCO. So the Energy in Buildings and Collaborations Program is one of the technology collaboration programs that are part of the IEA, and it was created in 1977. And essentially, this TCP has more than 300. I haven't counted them, but it's one of the things that we want to do. From 26 countries working on 18 projects, plus the reason why we are here, the Building Energy Codes Working Group. The mission of the EBC TCP is to support the acceleration of the transformation of the built environment towards more energy efficient and sustainable buildings and communities by the development and dissemination of knowledge, technologies, and processes and other solutions through international collaborative research and open innovation. More specifically, the working group is essentially has 18 member countries and 69 working group members. And overall, we have about 110 participants in our webinars and receiving our newsletters. The types of exchange, this is a working group as opposed to an annex, is much looser in some ways. And essentially, we share information. So like research and analysis on innovative code practices. We carry out webinars on latest code developments. we have quarterly newsletters highlighting our activities and do outreach and to disseminate findings and encourage improvement and innovation in practices as part of the codes. The link below, you can find all our information. It's available and it's on the website. So our work plan as it stands right now is what you see there. Like we have 3 new publications that are either just coming out or they are about to come out. In Natural Resources, Canada is contributing the resilience to overheating paper. Australia is providing information on embodied carbon in building codes. And there is work with ASHRAE to explore flexible codes for hot climates. As we go forward, the following topics that you see there are under consideration. So we are going to continue with energy resilience. We are going to start to look more in detail about performance standards, as well as building electrification and its implications to the codes. I think this part is already published about innovation and compliance techniques. And maybe in the second part of this meeting, we are going to have that. And we are going to be discussing about new refrigerants and performance for code references. The agenda today. So we have 2 sessions. The first one is a series of presentations, 3 presentations specifically, that I will let the moderator introduce. And it's on modern building code approaches to resilience and multi-hazard mitigation. The second one is going to be a panel discussion, so it's a little bit different. It's a 45-minute panel discussion with those panelists that you see there. So I am going to pass it on to Dr. Ellen Franconi, who has been active in the building science field for over 30 years. And over the past 7 years, she's worked at the Pacific Northwest National Laboratory, supporting the US DOE efforts to advance building energy codes. Her efforts include the development of methods to quantify the value of building thermal resilience in codes and standards. So I'm going to pass this on to Ellen.
Right. Thank you, Melly.
I stop sharing.
And thanks for everyone who's joining the webinar. You probably are already aware of the important role that building energy can play to serve as a critical prerequisite for achieving energy efficiency and thermal resilience in building design. And they can support hazard mitigation preparedness by addressing extreme temperature hazard risk. Historically, though, resilient benefits of energy codes haven't been widely recognized, since this impact is seldom quantified. During last year's symposium, I shared results from a US DOE research project that I managed, which was a collaboration between 3 research labs, PNNL, LBNL, and NREL. It focused on developing methods to quantify the thermal resilience benefits of improved energy efficiency. And we demonstrated the method by applying it to existing buildings in 5 different locations in the US. And we demonstrated their resilience characteristics in current conditions, current published code conditions, and stretch code conditions. So in this year's symposium, in this panel, the conversation continues. But the speakers are expanding the scope to also address the multi-hazard benefits that building codes, beyond just energy codes, can address. So as Melly said, we have 3 speakers. Each session is 20 minutes, including introductions and presentations and Q&A. So I do ask, if you have a question that arises during the presentation, please do post it in the chat so we can have them all compiled by the end of each presentation for the Q&A. Right, so our first panel speaker is Mr. Ryan Coker. Mr. Coker is the International Code Council's Executive Director of Energy, Resilience, and Innovation. He works to identify emerging issues in the building industry, including how new technologies can be leveraged by codes and standards, methods to modernize the application of building regulations, and the development of new business strategies that support building safety professionals. He also serves as the Executive Director of the Alliance for National Community Resilience. So Ryan will be presenting on the resilience benefits associated with modern energy codes and opportunities to even further enhance resilience through a holistic approach that considers building codes in their entirety. So welcome, Ryan, and I believe you're joining us live from COP30.
I am, and really do appreciate the opportunity to be here today and share a little bit about what I'm seeing relative to sort of the intersection of resilience, hazard mitigation, energy efficiency, embodied carbon, and sort of all of those pieces. Let me first give a sort of quick background on ICC and particularly, sort of why we focus on, all of these issues. So, ICC is probably best known for the development of model building codes and standards, which are used in the US, but also internationally as well. And then really looking at all of the sort of pieces that make those codes effective. So you can have sort of the greatest codes on paper, but if you don't have the tools to actually make them work and implementable, then, what have you really accomplished? And so looking at things like product evaluation, training, certification, Ellen mentioned the work of Anchor, the Alliance for National and Community Resilience. So looking from a very holistic perspective at benchmarks to support communities and understanding sort of where they are today relative to their resilience and where they can go into the future. And so, sort of picking up on that holistic approach, we really have the opportunity to look at multiple different avenues to get the best performing buildings that we can possibly get. And so ICC really supports the development of 15 model codes that cover the breadth of the built environment. So, this group is probably most familiar with the International Energy Conservation Code and maybe the International Green Construction Code, which is based off of ASHRAE's standard 189.1. But we have other sort of mechanisms to get to sort of resilience. And so it's things like the International Zoning Code or the International Wildland Urban Interface Code, which addresses, the growing risk around, wildfire or bushfire impacts. We have the International Building Code and the International Residential Code, which really sort of sets the foundation for disaster resilience and expectations of performance in disaster events. And, sort of two other sort of codes I'll mention, International Existing Building Code, which really addresses, how do we get to more sort of resilient, energy efficient existing buildings. And then the International Property Maintenance Code is how do we keep those provisions that we design within buildings to give us energy efficiency and resilience? How do we keep them going and assuring that we're continuing to deliver, sort of on those mechanisms? As Ellen mentioned, I'm at COP here in Belém, Brazil. So I thought it would be important to talk about sort of the growing international focus on sort of bringing the concept of, sort of low emissions, energy efficient buildings and resilience together. Sort of the concept of climate adaptation and mitigation really as sort of two sides of the same coin. And we can't really talk about one without talking about the other. And so the Buildings Breakthrough came together a couple of years ago, led by France and Morocco. governments really sort of aligning around a near zero emission and resilient building future as the new normal by 2030, and really recognizing sort of what are the actions and things that need to happen to actually get us there, and how do we collaborate. So I think there's about 27 countries that have signed on to the Buildings Breakthrough. Two priority action areas of note. One is around standards and certifications, really trying to get sort of alignment around what do we mean when we say near zero emissions? What do we say when we mean resilient buildings? And what are the building blocks that are really going to get us there? And then priority action area 5, which ICC is actually leading, is around capacity building. So how do we make sure that both the institutions and the personnel that we need have the tools, the skills, the resources to get us there? Related to that is the Declaration de Chaillot, an Intergovernmental Council on Buildings and Climate. These are the often sort of cities or buildings, ministers from around the world that come together to develop policy recommendations, statements, provide technical assistance. I think currently we're about 60 ministers around the world that support the ICBC. And you see one of their sort of key recommendations there. From the private sector side, we see the Market Transformation Action Agenda, really looking at sort of how the private sector can drive things forward. And intervention 5 within the action agenda is standards alignment. So thinking about sort of how codes, standards, and other tools can really help drive us forward, both again on the emissions and on the resilience side. And then also, some key folks sort of in the space, World Bank, OECD, UNDR, and IEA as well, really looking to, sort of continue that broad dialogue. And so, when we talk about sort of the opportunities that codes provide to support resilience, I think this is a great example out of the U.S. Federal Emergency Management Agency, but could apply anywhere. Codes really lead to less damage, which makes sort of families more stable, more resilient, being able to shelter in place, which then feeds into the opportunities at the community level, looking at sort of infrastructure, public health. And then, from a government perspective, less need for response, more stable economies, and really sort of looking at those trickle-down effects that really start with the foundation of good building codes. And so, as we look at, as Ellen mentioned, energy codes are not just about kilowatt hours or BTUs. There are other benefits that come along with energy codes. And certainly the more that we can illustrate those benefits, really the more opportunity we have to sort of highlight where the opportunities are, and bring sort of more folks to the table. And so, again, it's looking at things like energy codes supporting durability, because you don't have, moisture damage from, sort of rot, mold, mildew, opportunities in the fire safety space as well. Certainly a, sort of well air-tightened building reduces the opportunity for fire spread. We can talk about sort of in the wildfire context, even far away from, wildfires, we're seeing, smoke and other, sort of pollutants impacting folks' health. And so having, sort of good ventilation strategies, filtration strategies, support, sort of resilience in that space. And so this report is a little bit older, but really sort of lays out a lot of those sort of co-benefits. And so, we sort of dug a little bit deeper. Again, this is based off of the 2018 Energy Code, but certainly parallel, sections of 2024 code as well, really sort of tying specific energy efficiency strategies to resilience strategies. And so things like insulation support passive survivability, reduce energy burdens, which certainly support social resilience of the community, reduce grid impacts, which provides sort of everyday grid resilience, but also when we talk about sort of disaster events, being able to sort of bring the grid back up more quickly. And so sort of really getting to that bigger picture. There's also been some work out of ACEEE, American Council for an Energy Efficient Economy, sort of looking at from the flip side, what are the benefits that we see, relative to resilience. So things like emergency response and recovery, social and economic value and resilience, climate mitigation and adaptation, and then how is that sort of linked to energy efficiency? And so you see similar, sort of types of sort of connections, backup power supply, and being able to better sort of respond, to disaster events, maintaining temperatures, relative to extreme heat or extreme cold events. And so, sort of really getting to that holistic vision again. I did want to highlight the report that, or the study that Ellen mentioned from the 3 Department of Energy labs, really getting to, again, sort of other benefits that come along with good energy codes, and really being able to enhance the passive survivability. So, how long can you stay comfortable, healthy, within a building that does not have power, but is in the midst of an extreme heat or extreme cold event. And you can see sort of in the middle purple, application of the 2021 IECC, bends that curve and gives folks, additional time to be in their home, additional time for, the grid to come back up, which means that the sort of local shelters, don't, need to house those people. And so, there are, continued opportunities to, incorporate maybe in a more holistic way, passive survivability into the energy codes. I will say sort of for, most codes, currently this benefit is just an add-on. It's not something that's, sort of thought about from the very beginning, but we're already getting significant benefits from that. And so if we have the opportunity to maybe look at passive survivability opportunities from the very get-go, we can be sort of very deliberate about what the strategies are to be able to achieve that. And then sort of picking up on the sort of need to look beyond sort of the resilience space to concepts of circularity, and really starting to see some great intersections, some common sort of goals. You see them at the bottom around sort of adaptability, durability, and so sort of being able to talk about resilience and circularity together as really a tool, to be able to enhance both energy performance, emission reductions, and the resilience of buildings and communities. Don't have time today, but also thinking about some of the other sort of strategies that folks are thinking about in the code space relative to sustainability and resilience opportunities. Offsite construction, built in a factory, provides much more precision, much more sort of engineered, focused approaches. And so you can think about sort of higher quality buildings with energy efficiency strategies built in. But also on the offsite construction side, if we think about sort of opportunities for disaster recovery, often offsite construction can be quicker than site built. And often, the offsite construction can happen in a factory outside of the community. And so you don't have the stress on hotels, shelters, food, within the community itself. We're also seeing an increased focus on extreme heat. IECC, for instance, has had requirements around heating for a very long time, but cooling has not been sort of a key strategy. And so thinking about sort of with the growth of extreme heat, what do we need to actually address those issues? Certainly seeing an increase in interest in energy storage systems to help smooth out some of those challenges on the grid, but also, sort of recognizing that there are some challenges, relative to the safety of those systems and just making sure that they're being used effectively. We're also seeing, focus on grid interactivity, recognizing that, buildings can be both a suck on the grid, but also a contributor to grid stability. Certainly electrification as part of that, which then ultimately, sort of is interconnected with energy storage systems, renewable energy, and sort of other strategies as well. And then, one area that is certainly emerging as we continue to get sort of more efficient on the operational side of energy use, embodied emissions certainly becomes a sort of key part of the code conversation. And so, folks may be familiar with this diagram, really covering sort of the life cycle of buildings from the very products that come together to the end of life. And thus far, we've sort of focused a lot on the operational side. So I mentioned the energy code, residential code, green code, plumbing code. We've gotten sort of pretty good on focusing on sort of operational energy use. We've started to focus a little more on sort of the product level. There are provisions in green codes. We have environmental product declarations, which are certainly coming to the fore. But sort of how do we bridge that entire sort of life cycle again to have a sort of coordinated approach that really looks across the entire life cycle. And so working with ASHRAE, we're developing ASHRAE ICC standard 240 for the quantification of life cycle greenhouse gas emissions, really being able to optimize across that entire life cycle, really understanding that there may be solutions that have more embodied carbon up front, but deliver increased efficiency, reduced emissions across the entire building life cycle. And so how do you really look across sort of all of those pieces to be able to optimize against those particular goals? And so I think we certainly see that as one of those emerging areas relative to codes. And as I mentioned, as we talk about sort of the intersection of resilience and circularity, there are those opportunities to sort of continue that dialogue. And so we expect to see standard 240 out early next year. So really providing a great opportunity to get to consistency within the built environment. So I think I'll stop there. Certainly happy and interested to continue the conversation. And if folks have additional questions, please do reach out. Always happy to chat with folks, and appreciate the opportunity.
Great. Thank you so much, Ryan. Super informative. Just have any questions? So we've got about 6 minutes, I guess, for Q&A, or a few minutes. Has anything come through the chat, Matt?
No questions in the chat yet.
I have some. So it was really fascinating. Ryan did such a nice job of showing how within energy codes itself, it addresses multi-hazards, but then there's also, looking more over the life cycle and the relationship with other codes. Can you just talk about, how you go about kind of creating a work product or helping professionals who are trying to make connections between things within the ICC, since you are, publishing these 15 model code documents?
Yeah, so certainly, a few ways, within the codes themselves, they are very coordinated, and it's certainly a deliberate, sort of connection across the codes themselves, recognizing that we need to have sort of that holistic approach, and being able to, as we talk about, sort of water or plumbing related issues, for instance. We have the plumbing code, but bringing that into the residential code and the building code, and being able to sort of coordinate provisions, make sure there aren't conflicts, and those sorts of things. But beyond that, there are some sort of really key areas that help support professionals within the building space. So I did mention sort of training and certification as a key part of the solution set. And so, it's beyond just sort of the code itself, but looking at, the implementation side, as a key part of that. And then also developing, support resources that, sort of help make things work better, particularly as we look to sort of innovation within, implementation. So I know, sort of our next panel is going to talk about the role of AI. But we've developed some AI tools to help folks sort of better navigate the code, and really look at those intersections. We have resources to support remote virtual inspections, and so sort of being able to bring all of those pieces together, have that holistic view, but also engage the broad industry in identifying sort of what are the needs, and how to move forward. I think the other piece I'll mention is, as we look at sort of different innovations in products and materials, being able to give code officials and designers confidence in, the ability of those materials to meet code requirements. And so, through our evaluation service, we're able to look at those products, validate them, and certainly bring that confidence to the market, which then allows sort of scalability, and sort of quicker deployment of some of those new solutions.
Thank you very much.
We did have, Ellen, one other question come in from the chat. Ryan, you were talking about resilience and circularity. Are there any international examples where building codes have integrated both, requiring material reuse or adaptability?
So, I mean, circularity in and of itself is certainly an emerging space, and I think sort of it's born out of the sort of focus on emissions and resource use. I don't know that I have a very strong example, but we have seen some opportunities when we think about sort of long-term value of materials. So there are requirements in places like Portland, Oregon, where if you're demolishing a older residential structure, which often has sort of very robust materials, that a certain percentage of that building sort of needs to be reused. And so if we think about sort of the opportunities, the sort of emissions that have already been invested in those materials, we certainly get the circularity benefits, but also potentially from sort of that robustness, we can get sort of the resilience benefits. I will say there's a little bit of a sort of challenge in that space of sort of verifying that those sort of reusable materials are fit for purpose. Are they still meeting the performance requirements that we need? So I think that's definitely an emerging space where folks are still looking to sort of figure out what does that actually look like.
Thank you. Okay, well, thanks so much, Ryan. Really appreciate you sharing your expertise and perspective. Some real clapping and virtual clapping for you.
Thanks so much.
Okay, so our next speaker is Dr. Shadi Atiha. Dr. Atiha is a professor of sustainable architecture and building science at the University of Liège, Belgium. He directs a sustainable building design lab there. His research focuses on building energy performance, climate adaptation, and circular construction. Within the Annex 80, he defined the concept of resilience and developed key performance indicators, or KPIs, for quantifying thermal resilience during heat waves and cold spells. He is internationally recognized for bridging research, policy, and design practice toward resilient and low-carbon buildings. So Dr. Atiha's talk addresses recent European research and policy work with a focus on the IEA Annex 80 and the EPBD recast, and the introduction of quantifiable resilience indicators in energy codes. The emphasis is on bridging energy efficiency and multi-hazard performance beyond thermal comfort. Okay, welcome, Dr. Atiha. You can tee up your slides and
thank you.
Yep.
And then can you hear me?
Yes.
Great. So I'll start sharing. Here you go. I'll go in full mode. Great. I think you can see the presentation.
Yes.
Great. So thanks a lot for the presentation, and I will try to align the talk with the previous presenter. In fact, it's very interesting to talk about the circularity aspect. In any case, it's coming more difficult with regulation layers because we have the circularity, we have the energy efficiency, and we have the resilience. So in that context, I'm going to present the work of today, and the focus of my presentation is mainly on future-proofing environmental energy performance directive. The EPBD is standing for Energy Performance of Buildings Directive. This is the guiding framework that we are following in Europe. We have in Europe so far 27 member states, and they have to use all methodology to model buildings and estimate the energy efficiency and to define thresholds for performance. And in this context, I will link what we are trying to do regarding the energy performance of buildings directive with resilience. So before starting, I want to acknowledge a large team behind this work. It's not a single work, and when you say the International Energy Agency, Annex 80, it was a team of collaborators and researchers, and for sure I want to thank Matt Young also for inviting me to this annual symposium on building energy code. So this is a work that is full of collaboration and a large teamwork. Now, when we talk about multi-hazard resilience, we need to be more specific and we need to get more information about the type of hazards, because whether it's a drought, a flood, a heat wave, fire, blackout, there are more than 15 different hazards that are defined under the resilience category within the international United Nations framework. And the United Nations already developed a framework about resilience where they are defining the different shocks and the different hazards. So this is very interesting to follow as a document. And in general, modern energy codes, they can enhance not only the energy efficiency, but also the building and occupancy or occupant resilience from passive survivability to climate adaptation. So this is important to keep in mind. Now, when we talk about the definition of resilience, we need to take into account that resilience is associated with shocks. And shocks means that we must have a failure. We cannot claim that a building has a resilient feature without that the building is subjected to a shock or to a failure. And here we can see, I don't know if it's shown in the graph, I will try to get my pointer in red, that building performs normally is stable around climate conditions and design conditions. We have, for example, comfort in this case, we will have a certain threshold for performance. And then we can have some foreseeable extreme weather events without exceeding the minimum thermal conditions of comfort until we have a major event or a major shock that will lead to a failure. And as you can see, the failure means that we are exceeding the critical thermal conditions or the critical performance conditions, and we have a kind of stoppage. It stops, the performance stops until the building or the system recovers and goes back either to the critical conditions or the minimum conditions or the design conditions. So it's very important when we address the term resilience to take this into account and understand that we ask ourselves how long the building will withstand severe consequences of a shock and describe that as resistivity, and how quickly can a building get back to the acceptable conditions, and we call that recovery. And for sure, we need to look also at severity, because today weather files will not indicate the severity of weather, and therefore sometimes we need to create short events like short extensive heat waves, or like long extensive heat wave, or we create power outages and use these events to test our scenario in order to see what might happen during the summer, during the winter, whether it's cold spells or heat waves or power outages or any other shock that will lead to a failure and exceeding the critical conditions. Now, in Europe, a very important phenomena that is happening in the last years, that we are moving from overcast skies and intermediate skies towards clear skies and clear turbid skies. And this is a big danger for European climate, because unfortunately, in most modeling scenarios and in most weather files, future weather files, there is an underestimation of solar radiation. And there's many scenarios that the future will bring more humidity and rain, while in reality we are seeing in the last 20 years that it's getting more radiation and we are having a change of the sky. And very few studies are studying the sky. And it's very important because the sky is a very good predictor for what will happen and what type of weather we will have. So Europe is warming very fast, and one of the consequences of this change of the sky makes resilience a very important topic. So we are trying in this context to see what are the conflicting measures that could be contradicting when we are looking at resilience in the existing building codes. And we can see that, first of all, we have a conflict, for example, between the air tightness and ventilation during heat waves, because from one side we close the air or the tightness of the building, on the other side we are trying to benefit from natural ventilation. So this will be definitely one of the contradicting conflicts in relation to the thermal mass and to the shading. Also, another important aspect here is that we are going in Europe to a full electrification. So we will abandon fossil fuel, natural gas, and slowly also we will ban the use of nuclear energy by 2050. And while doing that, we will go in a full electrification, which will make us vulnerable to blackouts. So in this sense, also we have conflicting agenda, because from one side we are trying to increase efficiency and make buildings carbon neutral, but on the other side, we are increasing the risk and the stress on the whole electric grid in Europe, which is a very old grid and it is not coherent across the different member states. So this is also a conflicting measure in relation to resilience, and for sure we have a conflicting measure related to acoustics. We have in Europe now more and more urbanly dense cities, and we have less and less option to have single family houses. We are going to archetypes of apartment buildings, and this means that we need to make sure that acoustic and acoustical comfort is well maintained. But on the other side, we try to rely more and more on night cooling and day ventilation during natural ventilation during day. And you can see here the conflicting objectives that are coming. And the more we have the urban heat island effect, the less cooling in general through passive measures or airflow will be more effective. And for sure, the dependency on photovoltaics creates also problem with power outages. It's not a surprise that we find today a lot of neighborhoods, they are cut from the grid because they have overproduction of photovoltaic. So we see here a big complexity that we need a lot of storage capacity, but because of the surge of use of electric photovoltaic panels, it's a good beneficial measure, but on the other side, it fire backs on other aspects. So resilience and efficiency are not mutually exclusive, and we need to clarify the design intentions to avoid the clash when multiple hazards are present. Now, when we look at another important aspect, which is the quantification of thermal resilience in buildings, we can see that we have different risks like overheating. We look at thermal autonomy. We want to make sure that the number of hours of certain indoor temperature remain within a comfort limits. And we have also recovery time problems because in this sense, we try to make sure that the building will recover within a certain time limit. Less than 6 hours, then it will be good. More than 12 hours, this will be a poor response. So we are trying to equip our building with this aspect, which is also a challenging aspect. And for sure, we are looking also to the adaptive comfort and the duration of the measure that will take. How far can we go with adaptive comfort measures? We have the ASHRAE already. ASHRAE 55 has an adaptive path, while the SEN 16789, the European equivalent of ASHRAE, has different thresholds, and we find other standards like the Dutch ISO that has more tolerant adaptive comfort. So today, adaptive comfort is becoming a more and more flexible measure, or having a flexible band, which will be very complementary with the resilience concept, but until where we will accept certain limits of comfort. And for sure, the hygrothermal stress index, which is very important. Europe is a continent with a lot of humidity problem and rain. So those will be also very important quantifiable resilience indicators that need to be integrated, or they are now taking part of some new standards on a national level. So the key performance indicators can inform the life cycle impact assessment overall. By weighting the resilience indicators, for example, indoor overheating or recovery time, based on event probability and duration, we can bring these KPIs or key performance indicators in the European or the Energy Performance Directive in Europe. Now, we should be realistic and we should see what's happening on the terrain. In reality, today in Europe, there is a lot of implementation barriers, and we can see that there is a lack of harmonization. Europe needs resilient metrics that also can guide the renovation wave, because actually we are renovating buildings by adding a lot of insulation, airtight, making the building airtight, and on the other side, we are facing warming, global warming, and a planet that is getting warmer and warmer. So we can see a very clear misalignment between the public perception and the climate reality. And the energy performance of building directives legal mandate is very energy centric. And when the European Commission tried to look more in the future, they transformed it from an energy centric to a carbon or greenhouse gas emission centric mandate. But this is not sufficient, because resilience is more beyond that. Resilience more is about catastrophes, hazards, shocks, disruptions, which means that while we are trying to reduce the greenhouse gas emissions and counter the global warming phenomena, we need also to live with these hazards. And still, the legal mandate for standards still are not sensitive to that. So we have a lack of harmonized link between resilience, key performance indicators, and life cycle impact assessment overall indicators. And you can see the previous presentation of Mr. Corker when he was talking about circularity. Well, circularity is strongly embedded in the life cycle impact assessment paradigm. So you can see that they are intersecting, and they will become on the agenda, top agenda in the next years. And for sure, something that many people forget about is that we have a very, very present policy saturation and fatigue because we have started our regulation in 2006, which was very strict, and every 5 years we update these regulations. We started with energy efficiency, nearly zero energy building. We went to zero energy. Now we are looking for carbon zero energy building and positive or plus energy building. And now we switch from energy to carbon. And while we are switching from carbon, the paradigm of circularity is pushing. And in the background music, we have the resilience paradigm. So this is all making a lot of necessity to update and to change and continuous modification. As a result, we have strongly bureaucratic administrations that are unable to follow the pace, resulting that we have a policy saturation and policy fatigue, and the overall stakeholders, they find it difficult, especially that we have a big divide in the society. We have businesses and private sector that is eyes on the ball and catching up and moving forward to the future, while the majority of public administrations and the citizens in the middle class or social class, they are unable to follow this change. So we can see clearly these are the problems, and for sure also the research and policy gap. Research is way advanced than policy because policy is based on consensus. So we have still a lot of things to implement to cross these barriers for implementing resilience metrics within the energy efficiency policy. So the energy performance of building directive should evolve from the efficiency based to a performance and risk based design. And this will be very important paradigm shift in the next years in Europe. I cannot say that we are there. We are even at the beginning. There is very little awareness about the term resilience and what it means. So I can more talk now positively on the future, and I can share with you what we are trying to work on. Well, we have good examples in Europe, and we have positive some positive implementations from energy only compliance to climate proof performance. For example, Denmark and France, they are standing as one of the few European countries that have a very good building regulation explicitly linking energy efficiency with carbon targets and resilience. And this is very interesting to follow and to witness how this is change is happening. What is now also happening, some discussions in the energy performance of building directive in Europe and some of the annexes, especially for the energy performance certification, is to add resilience performance indicators. Maybe we will not see that in 2028, but it's very clear that starting from 2023, 2030, we will have some resilience performance indicators that will be introduced in some national codes. And already it's happening now that we are coupling the life cycle impact assessment or the circularity concept with risk-based design to capture both long-term efficiency and short-term hazard performance so that we can bring mitigation and adaptation in the loop. So these are all good and positive signs. And for sure, it's taking time, but it needs to be pushed in the implementation that we harmonize standards with data and bring more EU protocols to cut the methodological inconsistencies and add certain threshold for thermal release resilience label. In Europe now, we are trying to find a label to say what is a resilient building. And this is more an initiative from the private sector with the rating systems. So from there, we are moving forward to combine a policy governmental approach with a private sector initiative, standardization or rating system approach, so that we also have a definition of what is a resilient building. Because like in any country, we need always to have examples or prototypes. If you remember how the passive house was a leading example that introduced a lot of change, we need some examples like that, that we first agree on what is a resilient house and have some experiences with some buildings that are implementing and adopting these concepts. So we can't regulate what we are not measuring, and we cannot regulate what we are not building. So there is the door is very open for the next year to have pilot project in this area. Well, this ends up my presentation of today. I'm available for your questions, and I'm looking forward for the exchange. Thank you for your time, and thank you for the invitation.
Great. Thank you so much, Dr. Tia. Can you hear me? Okay, my mic's been a little funky. Can you hear me?
Yes.
Yeah.
We
Okay.
can hear you.
All right. So we just have 1 minute. I see a question did come through the chat. So it says, you mentioned several conflicts like air tightness and ventilation, or the risk tied to full electrification. How do you think we can better balance energy efficiency goals with the need for resilience so they actually support each other rather than compete? Good question. I mean, that's so easy to answer.
Yeah. Well, thanks for the question. What we can say is that we have a lack of clarity. What's the building of the future? Is it a high-tech building or a low-tech building? Is it an autonomous building that can survive for certain events or certain duration to be completely passively operating? Or it's fully high-tech 24/7 with mechanical ventilation, with systems integrated, depending on the grid. So until we figure out this difference of high-tech, low-tech, and how far we can depend on natural resources. For example, cities will be different than rural areas. If I am in a very crowded city and the air is polluted outside, the urban heat island effect is playing a major role. I will be baked if I open the window. Then it will be very difficult in this sense to not rely on a fully high-tech building that has a lot of backup system with batteries and internal scenarios of functioning and operating. For example, we had a building, a senior house in Belgium, and the whole scenario was to evacuate the different floors during a heat wave if there is a power outage and assemble all occupant in a very cold place in this building. So here we rely a lot on occupant adaptation and behavior because we cannot open windows in this case because the building is completely operated with BMS or building automation system. While in other situations, when we are in a countryside or a rural area where we can open the windows, we are not afraid of air quality and we can operate, we have a low density, then the passiveness works very strongly. So it's getting now more complex on how, even when we teach to our students, when I tell them they have to make benefit from natural ventilation, I think we have today two regimes in the whole world. Highly densely populated areas and low density areas. And I prefer to develop guides and recommendations that distinguish those two different realities. New York, Hong Kong, big cities, Chongqing in China, is not like when we are talking about Denver, Colorado, for example. So this will make it also difficult how to make standards that are sensitive to this difference in general.
Thank you, Shadi. And I would just add to that, what's great about all your KPIs is that you can at least identify the conflict and then move from there based on all those considerations you shared. Okay, thank you so much. Again, real clap, virtual clap from everybody else. So we'll move on to our last speaker, who is Dr. Simona Bianchi. Dr. Bianchi is an assistant professor in the Restruct group at the Faculty of the Architecture and the Built Environment at TU Delft. Her research focuses on multi-hazard risk assessment, performance-based design, and sustainable building technologies. She has actively led and contributed to numerous international research projects, including serving as a technical lead on the Horizon Europe Multi-Care project on low carbon resilient technologies. She's received several prestigious grants, including EU-funded Marie Curie Fellowship and an NWO Veni grant, all to advance her work on climate and disaster resilience. Dr. Bianchi will discuss the need to integrate multi-risk considerations to enhance building resilience and long-term performance. Her presentation highlights knowledge gaps and the transition from a single to multi-hazard resilience approach, as well as key challenges to their implementation. So Welcome, Dr. Bianchi.
Thank you, Helen. Thank you so much for your introduction, and thanks to the organizers for inviting me to this very interesting symposium. I'm pleased to share my perspective on how to integrate multi-risk management and multi-hazard resilience into energy building codes, indeed especially focusing on what are the main knowledge gaps and the challenges to enable this transition from single to multi-hazard. Well, nowadays it is very clear the need for these resilient solutions for our built environment, and especially because too often cities, buildings, as we was further confirmed by recent events, unfortunately, they are unprepared to these extreme events, and these are causing a huge societal, economic, and environmental losses. Let's say that, for instance, if we think about flooding, so typically we refer to heat waves, cold naps, so more weather related. But when we think about flooding, this is also causing, for instance, damage impact to our building envelope. And this impact means that we need to replace, restore the building components, which means we are adding to the recovery time and also further, let's say, increasing the expected carbon emissions. But all these hazards are very country specific. So for instance, in the Netherlands, where I'm based, our Dutch Meteorological Institute is highlighting especially an increase in terms of heat waves, intense rainfalls, and strong winds. But we have also other many types of hazard, which are multiple and diverse, with their own intensity and frequencies that might happen. For this reason, when we consider resilience, especially for our building energy services, we should consider the strengthening of the capacity of these systems to respond and to recover against all these different types of hazard. And resilience is a concept which is even part of the broader disaster management, let's say, cycle concept itself. Typically, as designers, we mostly focus on the post-disaster phase, but we have also the pre-disaster to be considered, where we work especially in terms of mitigation. So, for example, how to quantify the risks, how to plan interventions, or to improve preparedness in terms of these smart technologies for providing alert systems or establishing emergency plans or through backup power solutions. Within our building codes, we especially focus on the operational capacity, so the operational continuity, let's say functionality during the event. And indeed, we have requirements, especially for passive survivability, to, let's say, understand the degree and duration to which we can maintain safe indoor conditions in case of a power loss. While in case of recovery, it's especially extremely important the restoration of the grid to power, and that is also that is relevant for all the different types of hazard, even if we think about earthquakes or even flooding. So we are especially focusing here, but we should account for a requirement for all these different phases as part of the disaster management cycle. And in the Netherlands, the need for integrating a resilience concept in the code is very, let's say, evident. We have, let's say, all these requirements in terms of energy efficiency, but we need to understand also the cooling needs for our buildings, because cooling is relatively a new issue in the Netherlands, so we need to build our knowledge about these cooling needs, especially the effectiveness of potential measures and policy instruments, and also what is the impact to the electricity grid, because in the Netherlands we have this goal of making Dutch buildings gas-free by 2050, so we cannot underestimate the electricity consumptions and especially, let's say, these peak loads. At the same time, we do see in the code the integration of some thermal resilient concept, although still in terms of only overheating risk, through the TO July or the developed heat label to classify our buildings. But as already shown by the previous presentation, unfortunately, we still miss within this single hazard resilient approach the definition of a standardized framework for resilience quantification or metrics or specific resilience targets for our buildings. And when we move to multi-hazard resilience, this is even more challenging. So in this case, it's fundamental to identify the type of interaction we might have across the specific hazard. We can have independent hazard like earthquakes and heat waves. We can have cascading hazard, so one hazard triggering another one. So we have multiple types. We need to identify what is the most probable multi-hazard scenario that we might have in the building life cycle. And it is not only important this temporal, so time dependency, but also the spatial evolution, because maybe a localized hazard can impact, let's say, have indirect impact to a larger zone, like we go from building to district or even a larger scale. Therefore, indeed, it's important to classify and, let's say, identify all the different hazards and this correlation to specific design measures to be considered in the codes. For example, the glazing design is used to reduce the solar heat gain, but can also be very beneficial to resist wind pressure in case of hailstorms, or the same applies to the envelope, just another example that indeed it's important for passive survivability during heat waves, but can be used to prevent water ingress in case of flooding. So it's important to map out all these potential complementary measures, thinking about the correlation with the hazard. At the same time, as already shown by Dr. Shedi Attia, indeed it's also the conflicting considerations that we can find actually in the code or related to our design itself. But also in this case, this is dependent on the type of interaction of the hazard. So the same heat wave can have correlated, in this case, a negative correlation with the cold snaps. So maybe some measures that can be beneficial for one can be the opposite for the other one, or heat waves can have a compound effect, like in case of wildfire smoke. And here, natural ventilation is very positive, while on the other side, we need to close the window to maintain indoor air quality. So again, we need to identify all these potential dependencies, correlation when considering the specific hazard interaction. Therefore, to advance our codes and move to this multi-hazard approach, this is the first thing that we should do, identifying for our specific, let's say, location, all the hazard, their interaction, what are the different systems, components that are exposed, and how to properly quantify the vulnerability of these elements. Because the vulnerability is the component that we want to reduce when we implement resilient solutions. It's also important to define holistic assessment methodologies, indeed standardized approach like defining acceptable thresholds for safety or maybe specific metrics. And these should be defined considering the overall impact we can have in terms of consequences in case of extreme events. So in the end, we can generate not single, but maybe couple or aggregated indicators that could be used for supporting holistic strategies. So it's important to balance in the end our design choices to identify what are the optimal trade-offs for these holistic solutions. And these indicators could be used for defining resilience levels for buildings, like we try to do in these initial publications, which is kind of similar what we have in terms of energy labeling system, but in terms of multi-hazard resilience scenarios. And indeed, this can be very useful if we want to compare alternative design or retrofitting options, considering the specific local multi-hazard, let's say, scenario that we have. At the same time, these indicators could be used also to derive risk-based matrices that could be, let's say, adopted into our performance-based design, which, let's say, tell us what are the acceptable losses when considering a certain intensity for the hazard or maybe the multi-hazard event. So in this case, we can identify these, let's say, from acceptable to even, let's say, high advanced performance that could be used for designing our solutions. And another important aspect is the definition of multi-scale mitigation strategies. So we are working a lot in terms of understanding what is the occupant to building, a component to building, a building to grid interactions, because in this case, our energy efficiency requirements can also improve the grid reliability. But we need really to account for all of them to enable a proper optimization and selection of the different layers of my building envelope or the different technologies within the building to have multi-scale benefits in the end for my, let's say, energy systems and buildings. To summarize, well, in these slides, I'm, let's say, reporting all the different key points that I have already mentioned and how it is important to move from this single hazard to multi-hazard, although for each of these domains, we still have research to be conducted. We are working on that. And I have to say that when compared to other disciplines, like if we think about earthquakes and seismic resilience, energy resilience is relatively new in our building codes. So we are working on that and we are, let's say, moving on towards achieving and trying to address those knowledge gaps. But there are also other critical areas. First of all, as already mentioned in the previous presentation, there's this need for advancing our knowledge. So we need resilience-specific trainings, especially for professionals, to properly enable the effective integration of resilient solutions into buildings. The availability, so new data about the behavior under failure modes. If we think about a building envelope in case of a long power outage, for example, and we need to integrate into existing digital tools also this resilience concept to support professionals into the implementation of these resilience strategies. There are also some challenges. Of course, when we think about analyzing the benefits, this can be very context specific due to the specific climate or buildings or let's say local materials available or even the specific occupants. But of course, what we are doing is working on a robust methodology that are scalable and replicable. There's another issue in terms of data, more than issue, challenge in terms of data interoperability. If we think about combining, for example, data, so recordings from sensors from earthquakes when compared to indoor, let's say environmental quality measures. And it's important to continue with the legislative and financial incentives, especially to promote and, let's say, continue with the wider uptake of these resilient solutions in practice. So I want to conclude just highlighting these two projects, Multicare, our Horizon Europe project, and Reclimate, funded by the Dutch Research Institute, where we are working on these methodologies and digital tools to support with decision making for multi-hazard resilient buildings. So thank you. That was my last slide.
Thank you, Dr. Bianchi. Very interesting how you took us from planning, preparedness, all the way, through to implementation. So thank you for that. One thing, I mean, in general with building codes, we address a lot of new building designs, but I know there's one program out of the Netherlands, Energy Sprong, which is more about retrofits, and it's been extremely successful. And I just wondered, Are you starting to bring resilience considerations into the benefits of that technique or existing building retrofits in general?
Yes, we are trying, especially in our, let's say, European project. We are, let's say, try to select a specific. So we are especially focusing on the envelopes at this moment, so the facade, and we are trying to identify specific resilience, let's say, performance indicators for each of the layer of the facade, and try to find the optimal combination to enable a resilience-based design of the technology itself. So that is what we are trying to do. Of course, it's a matter of validating the approach that we are proposing, and we are also, let's say, supporting with providing our, in addition to the approach, our catalog of potential solutions. But as I was highlighting, this can be, let's say, context specific, although we are not working only in the Netherlands. We have case studies from south of Europe and even from Romania. So hopefully we are gonna share also these implementation of resilience concept when that might lead direction to the directly to the selection of the specific integrated resilience solution. So.
Okay. Thank you so much. Really appreciate it. And applause for you. And also applause for the whole panel. Thank you so much. Very, very interesting collective presentations that were very complimentary.
Do we have time for another question, Ellen, or?
I think we're right at time.
Yeah. So we sorry, Clarissa, we'll have to. You can put it in the question in the chat, and we'll answer to the extent possible through that means. So thank you very much, Ellen. We'll end to the presenters, a very interesting session. And now we are going to be moving to our next session. And this is going to be on the potential of AI for building energy codes. To lead us into this discussion, which is going to be a panel essentially, we have Jean-Simon Venn, who is the co-founder and president of Brainbox AI, a global leader in autonomous building technologies. A recognized expert in HVAC optimization, AI-driven control, and climate tech innovation, he has led the development of cutting-edge systems that reduce energy use and carbon emissions across large real estate portfolios worldwide. Jean-Simon is a frequent speaker and advisor on the future of intelligent buildings and sustainable AI solutions. Jean-Simon, I guess the screen is yours.
Yeah, the screen. Thank you, Milia. It's very, very kind of you for the introduction. Hello, everybody. I will do just a quick intro because it's a fascinating topic, especially with the speed of the development of AI. It's kind of when we say it's a moving target, I think that's exactly what it is. So we'll jump into the panel very quickly because we have two guests with two panelists, which are like absolutely exceptional people, and we'll try to bring the overview of the field to the level where it deserves to be. The fundamental problem that we're facing is the building stack, the way I like to call it. Actually, we don't know exactly how many buildings there is on this planet, but let's say it's in between 3 to 4 billion building. It keep growing, right? We're very good as human to build more building, especially in density of a large city. So that stack is growing. It consumes about 1/3 of all the energy consumed on our planet on a daily basis. And it's been recognized over and over and over that it's not efficient. So there's about, like, depending who you talk to, there's about like 25 to 35% of the energy being consumed by this building, which is could be optimized, could be reduced. But we're not doing it at the scale that we should do it. So the entire equation that is in front of us is like, can AI be a tool to help us go harvest that 25 to that 35% of waste energy consumed by these 3 or 4 billion building every day? And if so, how can we do it? How can you put AI to work? So that's going to be basically the discussion over the next 40-something minutes. And it's my great pleasure to introduce the two panelists that we're very lucky to have with us. The first one is Dr. Nora Esram. She has absolutely an exceptional career. She's now the CEO of the New Building Institute. She launched so many major initiatives in the building energy rating, connecting home, healthy building, electrification, that it's on and on and on. She's been collaborating with over 400 organizations spread in a very impressive geographic footprint. 60 peer review paper, over 300 presentation in public event. So you want to listen to her. Keep in mind that she used to serve as a senior director of the ACEEE, and she was the chief engineer at the PNNL, which I respect greatly. So we're looking forward to have the discussion with you, Dr. Nora. Our second panelist is Dr. Along Wan, and well, I had a great chat with Dr. Alon yesterday, and his career is quite interesting. He became a member of the laboratory in October 23, where he's now like the primary research, basically focusing on building simulation. His expertise is pretty wild, as it goes from heat pump, refrigeration, and machine learning techniques. So you see the merge of the different expertise, which kind of bring us to an interesting discussion. But the key emphasis that Dr. Along bring is the system modeling and optimization of building. So right there, right on topic. So welcome to you too. And if everybody's ready, let's dive into the discussion. I think the first question would probably go your way, Dr. Along. And it's all about the discussion about AI for code compliance monitoring. So building code is a fascinating topic. It do vary from one country, actually from one state to the next, from one country to the next. So the question for you would be, if you want to launch the discussion, is how can AI and please encompass, like, computer vision, IoT sensor analytic, whatever is the source, be used to automate verification of building energy code compliance, meaning is the building compliant or not. And it could be like, envelope performance, but it could be the HVAC installation, or simply the lighting system, which is defective. So how can we use AI in that kind of application?
Yep. Yeah, thanks for the introduction, Jess. So yeah, again, this is Hanlong. I'm a current research engineer in PNNL, and my current research interest is more on the generative AI and natural language processing, especially for code verifications for the building field. So yeah, really thanks for these questions, and I'm very happy to give some thought on this, and hopefully can have some really good discussions here. I will also listen to every three very helpful presentations earlier this morning. So yeah, first of all, when we talk about AI technologies, I first want to say that what kind of AI technologies that we are discussing now, right? We have, like as Jess said, we have computer vision, we have IoT sensor analytics, but I guess the most popular topic nowadays is generative AI, and which is the large language models. I guess everyone, not sure if everyone really here have using the ChatGPT or Google Gemini or Claude or any of the very advanced large language models and chatbot. So I think it should be very helpful for the building energy code, since most building codes nowadays are written in natural language, right? They are in mostly PDF files, and LLMs and natural language processing can, of course, play a significant role in this area. So, for example, they can quickly enable QA process for you, or information retrieval, or document exploration, right? So, for example, you can upload an open source building code, for example, local code in PDF format to a chatbot, for example, ChatGPT, and you can quickly do some QA or content extraction. For example, you can ask what is the U value requirement for a specific type of envelope, and it can quickly give you the answers. So I think, of course, this is very helpful for the building energy code compliance process that you mentioned. And so for other technologies, I think, for example, computer vision, of course, are also very helpful for this field. So still use our previous examples. I guess for most cases, the building design plan mostly is in the PDF format, right? And usually you only have the scan copy, right? So, and you want to know the design details, for example, the geometries, right, of your envelopes or of your zooms. So in this case, this is how the computer vision can help you, right? In this process, it can give you a very helpful tool to help you to automatically extract the useful information from your design document, maybe a scan copy or just a digital PDF file, right? So it can quickly help you not manually reading these parameters. And similarly, I think the sensors can also help you to quickly collect the real-time on-site data and to support your code verification. And there's also some other potential technology, I think. I'm not sure here everyone knows Geographic Information System, which is GIS, that can extract the information from the digital maps, which can maybe give you a hand on supported retrofit analysis. Yeah. So yeah, I think all these AI technologies can be very helpful to automate the verification process of the building energy code. Yeah, thank you. This is all my thoughts. Not sure, Nora, if you have any additional comments on that.
Well, thank you. Well, thanks, first of all, thanks for having me, and thank you for this timely discussion. And just to build on what Dr. Wang you just said, I agree that AI holds tremendous potential when trained properly. Multiple techniques that you just mentioned can pull information from different sources and help connect the dots. But I want to address what John Simon, you just asked, the verification process, right? I feel like the verification process, that piece is just it's just isn't there yet. I would say code compliance can be a daunting task given the numerous code versions, regional variations, at least in the US, and sometimes the way codes are written can lead to different interpretation. Unless you're a codes expert, you know how to read those language. So the ability to understand, interpret, and navigate these nuances may take a lot of learning, training, and practicing. So how the AI training is designed and how we ensure that AI reliability will be a critical factor when we're able to take advantage of these tools and just to apply to the code compliance.
That's quite interesting. But so you would say, like, that basically the main challenge is the data verification that prevent us to move forward, right?
Yeah, I think I would say, you know, for a general audience of codes officials to build confidence in AI-assisted code compliance tools, let's just call them like, restrict our topic to energy codes. I will want to understand how the AI training is designed, how its performance is benchmarked and evaluated, right? We have similar benchmark for modeling tools, but we do not have similar for AI tools. So a human-in-the-loop process may be necessary for a period of time until we can fully trust the AI agent. Then the question become, when we'll see a return on investment. Is it really saving me time? Hopefully, eventually will, but let's build the trust. Let's have human in loop, and then we can talk about business. That's how I
And
see it.
yeah, Dr. Allen, like on your side, like would you agree with that, or do you see other challenges more maybe on the data quality or the deployment of sensor, which is always a huge challenge? What's your opinion on that?
Yeah, it's me or Nora.
Yeah,
So
Dr.
yeah,
Allen,
So yeah, maybe I can talk more about that, my feeling on the data qualities on that. So I can still following up the my previous discussion, my above discussions that so still talk about maybe design file as an example. So although most modern designs are created in the CAD software, right? So and they should have some digital format that's stored on the behind, for example, Revit. I guess maybe some people are familiar with that. And but however, these files are not always available throughout the entire construction lifecycle. So maybe the designer has that, but in the whole life cycle, maybe for example the building owner or some operators, they are not have access to that digital file. They just have the a PDF copy or maybe just a scan copy of their file. So this, of course, can create us the challenges, for the data extractions on that, and that of course can bring the challenges. For example, if you rely on human to read their information and you extract the information there, it can bring some uncertainties or some possible mistakes that on some parameters. I think that is also a common mistake that on the code verifications on site, that the information has a gap on the design file, but compared with that on site. So that can definitely give AI a chance to help you to solve their gaps. For example, we have OCR, which means you have some specific computer vision tools that you can automatically load the geometries from even the scan copy. I should first state that this technology is that not ready for full file extractions. For nowadays, it can only extract some files with font in good format, right? If you have taken a look to an architecture design file, you maybe know that some numbers in that file is not in a regular form that we know. For example, it's not Times New Roman, right? It's in some special font. So it will give challenges for AI nowadays to detect the right information. But I should say the AI industry is growing faster, right? So what is there 5 or 10 years ago is very different from nowadays. So when that technology is ready, I think it will definitely give us a very trustable ways to get the information directly from the digital files that behind the scan copy file. So and that can of course on one hand, right, guarantee the generated content quality and give us some more trust on the AI content. I know this may not fully answer Nora your question that we bring out, but I think it can answer the questions on one angle, right, on how we can correctly get the accurate data without too much human efforts there, but it's all fully automatic, right? It can guarantee the code verification results. And beyond that, I want to share one more thought on the sensor side. I think you know the IoT sensors and all of sensors, they are also I'm not sure if we can see that as AI tools, but I think they are also one advanced real-world application technologies that may help us, right? But I think nowadays we have one gap here is, is between the researchers, the consultants, with the on-site operators and maintenance staffs. From one of my previous research projects, it's in a bag. So we spent a long time with them to analyze the energy consumptions, right? Because they report us that they have extremely high energy consumptions of their buildings. And we studied, we do a fully energy evaluation study of their building, but we finally find out that it's due to wrong installations place of the outdoor unit of their HVAC systems. So they put their outdoor units just inside the two very close walls outside. So it it harms the ventilations of the HVAC outdoor unit, right? So it have very bad heat transfers. So that's one of the main reasons that why they have such a bad performance. So I think this can give us a very a hint that even though before the on-site process, everything is good, everything is successful, but there still could be some gap on the on-site operations, right, compared with what is in the design plan. So I think that can also, it's not the AI side, but it's also bring such application of AI tools or advanced tools in the real world code audits, some challenges.
Yeah, it's quite interesting. And I fully relate with what you were saying. I think the fact that you get visibility on what's going on, suddenly you start to see a lot of things which make no sense. But at the same time, since nobody was really looking at it, nobody knew it was not compliant. So like, right. Just to provide visibility and forget. We have not done any kind of analysis yet, but just giving visibility, you start to see all kind of things which like, who did that? And don't go there, right?
Right.
Don't go there. Okay, so let's pivot from like code compliance to, okay, we want to change the code. How can we make the code better? And can we use AI tool for modeling, simulating the impact of somebody has a great idea, like let's change the code for include this. Wait a sec. Should we try to see what's the real impact before it become code? So what's your view on this? Is it a dream or it's reality?
Yeah, I think it's very reasonable. It should, of course, be reality. So I think I can still answer, not answer. I should just state some of my opinions in different angles. So first, still talk about the large language models. I think although it's very new in this field, but it could be very promising. So beyond my examples of QA and information retrieval, I think one of the biggest advantages of large language models is that it can help you to not fully automatically nowadays, but it can give you a lot of hands setting up a building energy model, right? And the building energy model, I think, is the base or basic of the of the building code, building energy code setting up, right? It's we set up that based on the building energy model. And building energy model, I'm not sure if everyone here are very familiar with Energy Plus and the IDF file, which is the source files of behind the Energy Plus. If you have a chance to take a look to that, also it's nothing special, right? It's just a text-based script. And of course, we can consider it as a natural language based script, right? So we know the large language models nowadays, for example, ChatGPT, it can help you as a code copilot for the C++ or for Python code. So of course, there's no way forbidden you, right, to use large language models to write the IDF file directly. So I think the biggest help for the LLM on the building energy modeling is it can lower the threshold of the entrance to the domain of people, right? So in the past, only the people that has been trained for a long time, maybe 1 year, 2 years, very specific in these areas, has the technologies to set up a building energy model. But nowadays, it is very easy for you, even not have too much experience on coding, on scripting, on Energy Plus, but you can still use the help from the large language models to set up a building energy model. I have two examples. So for one example is you can imagine you already have an IDF file on hand, right? You have a building energy model that you download from the internet, or it could be set up by your colleagues, right? You're a building expert. But now you want to analyze the impact if I reduce the window to wall ratio by 10%, right? This is a very simple examples in the code development. And you can use an AI agent which is an AI system that processes information and takes actions automatically based on your natural language inputs. You can use this to support you to automatically revise the IDF file baseline that you have. It adjusts the window to wall ratio values in that file, and it recall the Energy Plus to run the full simulations. And it can compare the simulated results with your baseline model, and it can tell you the impact of this, of this change on the energy code, right, in a specific location, for example, New York. So in all this working flow is automatically, so there's no specific knowledge required for the Energy Plus side. You just use natural language to communicate with the AI agent. So I think this would be a very good examples that how AI can help you, fully automatically and without any special knowledge required on the Energy Plus, to run the simulation and to check the impact on the energy code impact in a specific location that you have interest. Yeah. Another example could be, this is the example that you can have only this year, not before this year, because the involvement of the large language models, for example, ChatGPT. Based on my experience, in the year before, if you directly ask ChatGPT to generate an Energy Plus model for you, it's fully impossible. But starting ChatGPT 5, if you give a try, you can now open the ChatGPT website, you can give a try, ask that generate energy models. If I'm in, for example, Washington, Richland, it can very quickly generate you a fully complete IDF file for Energy Plus simulation, and you can use that directly. So of course, this could also be very helpful for a non-expertise, to analysis the building code evolution or building code revision or building code impact. Yeah.
All right. So thank you for that. Dr. Nora, if we look at the migration we're starting to see as regulation move from like a prescriptive, follow the recipe period, to like a performance-based or adaptive code-based building specification or standard. What's your view on how can AI play a role, but also like thinking about what kind of safeguard can we put in place if we give the key of the building to the AI to make sure that it's going to be robust and we could trust it. What's your view in that entire new field, which is evolving quite rapidly, right?
Yeah, absolutely. Well, whether we're talking about performance-based codes for new buildings, which we have been discussing for many years, or the new emerging building performance standards for existing buildings, right? Building performance targets are set without prescribing exactly how to meet them. These approaches rely heavily on modeling tools to achieve the desired outcome. Often while keeping construction costs as low as possible, right? That's kind of the target, meeting the standard without increasing costs that much. To me, it's really an optimization challenge. As we have discussed, Dr. Wang, you presented, AI-assisted tools could allow more people who aren't modeling experts, including myself. I'm an architect by training, right? I'm always spend half of my time do the design, the other half time wrestling with the tools. So it's a lot of people like me to use energy models and run analysis without those specific training. That can lower the project cost by reducing the need for dedicated modelers, cutting down time spent on troubleshooting models. That can be another daunting task, or even letting AI spot patterns or generate optimized solutions faster. So I can foresee money saved during the design means more resources can go towards construction retrofits. That's a big win. Another potential gain is really creativity. Jean-Simon, sorry, I mispronounced your name a moment ago. As you mentioned, do we want to test this in this location, right? The performance codes based codes let you trade off different design measures to find the best solution for specific building and specific location. It's better than prescriptive codes. We know that, but because it's a lot easier to use the prescriptive codes, that has been the mainstream. So that flexibility can really drive innovation, in my view. But there's always a but, we need guardrails. To meet the guardrails, meaning minimum energy and performance requirements cannot be compromised. We need to clearly define which trade-offs are acceptable and which aren't. For example, we wouldn't let AI to design windowless buildings just to save energy. We're not going to have 100% outdoor air solely just to improve indoor air quality. Or use low carbon materials has been another trending topic. But if those materials are toxic or shipping long distance around the globe, that's not what we're looking for. So you have to put all of this. I think humans need to think through all of this minimum requirement. As AI applies this multi-dimensional chess game for us, the minimum requirements have to be crystal clear for them. Then the solution is not going to fail. That's how I see it.
Quite interesting. Okay, so let's pivot back into what you mentioned at the beginning of the panel, Dr. Honora, and it's the question of the data. And like at BrainBox, there is now the say that we're interfacing with a jungle. So how are we supposed to run AI on a data source which is like very unstable, should I say, difficult to predict, very huge variation of quality. And when I say unstable, I mean like suddenly, that point coming in telling you it's 62 degree and that room become like 600 Fahrenheit. Of course, it's it's an error reading sensor problem, but like don't feed that to the neural network because your output will be out of whack, right? Of course, it's not 600 Fahrenheit in that room. So that what I call that data ecosystem and interoperability wall. What's your view on how we're going to put the effort forward to build an open and interoperable data ecosystem? It sounds like a daunting task. What's your view on this?
Dora, do you want to go ahead? Okay, yeah.
Why don't you start first?
Okay, yeah. So I think I'm not very expert to answer these questions. I can just still just speak one or two more of my thinkings on this side. So I think open to a pool of high quality data is always welcome and beneficial for AI technologies and machine learning technologies, right? And the more accurate or relevant data, the better AI system can perform, of course, right? So, but however, I think establishing a database may require carefully planning and coordination, and I think that could be what Nora, you can help us to address more on that. But I can give one example thinking that in my mind immediately is I'm not sure everyone here knows Comstock and RedStock, which is a research project that led by the DOE building code. Not building code, but the building technology office. Yeah, so I think they are quite a good open source of building energy modeling that open to everyone, that stores the energy performance around United States of some virtual buildings. So if there are more data sources like that will be open, especially cover all over the world, I think that will be very helpful for this domain. Yeah.
Yeah, so I do see there is a role for the public sector or the nonprofit sector, leading some of the data standard development while working with the private sector, right? There are several aspects of the question you just asked. When I work at the Pacific Northwest National Lab 10 years ago, my team was involved in DOE's Department of Energy's building technology office effort to create data centers and repository. That was like way before AI, but we're already facing the data challenge with some of the tools. We created, so-called building sync, EBC, the BPD, a lot of acronyms. I'm happy to, share more after this protocol what those are. The goal was to improve consistency and interoperability across building data sets. Some cities at that time have adopted adopted these standards and even published anonymized benchmarking and performance data. So these data sets can be really valuable as training set for AI application. So that said, we still have a long way to go to connect those dots. I don't think we have the shared data infrastructure that links building characteristics, operations, and energy outcomes. I think this is really where the private sector can demonstrate, right, how they can connect the fragmented sensor data, as you both probably have more experience in that space, that I have heard. And AI is really good connecting this data islands to create rich data sets, because this was like a very time and energy intensive process. Data cleansing and translation eventually you can use. I think that demonstration of success needs to be in place. Of course, the third leg of the tool is really the legal framework regarding data privacy, ownership, and intellectual property. There are two probably major players in that place. The first is utilities, and they're very protective of their customer data. The second piece is really maybe the design and engineering community. I was at the Greenbuild in LA last week. There were lots of conversation about AI to facilitate design process. And one concern architects and engineers raised is that their design drawings, construction documents are their creations. Why would I give this to software companies, or especially for-profit, to build tools that might one day replace them? So you do see the tension here. They want the benefits, but they want to make sure they're not really, I don't want to name the bigger companies, but they're in that space, right, to take jobs away from them. But they do comment that, they're open to share their drawings for regulatory purposes, for common good, if it's done in the nonprofit sector. So I do see there are ways to move forward and just to, really fully realize the benefits of AI tools. And as Jean-Simon, you said in the beginning, how do we reduce the waste of the millions of buildings on the planet now?
Yeah, at scale, and very interesting. I might just tell you, like, it was last week. I was in a meeting, and there's a startup in North America that basically used Gen AI, and of course it's energetic, to produce residential architecture plan that factor in the city regulation and the state building code, and they do that without the human loop. And of course they charge a lot less than if you hire your own architect. And then there was this architect firm which was trying to explain to me like that they will never believe that that's going to happen. But that startup, I think I already have like a million user. So it's happening. How do you make this happen? And at the same time, how do you get the buy-in of the professional which are looking at the tool? And it's absolutely a fascinating topic. We should do a panel just on this to figure out how do we manage this, because it seemed to be just happening, and it is what it is. Okay, 5 minutes left. Future horizon. Usually this question goes like, how do you see the next 5 to 10 years, and give me your vision of the future? But since AI is moving so fast and the shelf life of AI generation is about 6 months, I'm going to reduce the scope to give you a break to both of you. So how do you see the 1 to 2 year coming up how are we going to be impacted? What's going to be the inflection point? How the disruption? So very quickly, both of you, 1 or 2 years. It's not that bad of a call, right? Like, give me your vision.
Yeah, thanks. Yeah, I really agree that it's a little bit impossible to looking forward in 5 to 10 years what will happening, right? So because the world involves a lot, right? Everyone know 5 years ago we will not have the capability to imagine what will happen today. So yeah, I think 1 or 2 years may be more clear in this field that how we see that AI could touch base on the building energy codes. So first, I think the AI of course is like benchmark or verifications, like all of you mentioned as the earlier in these discussions. Yeah, I think tools that can automatically draft, summarize, or reformat code languages, and in the workflow, of course, we need maybe automatic, but also maybe human in the loop or any other approach. So how we can make a standard benchmark for the AI generated contents, especially for the building code and building energy modeling. I think that will definitely be happen in the next 1 or 2 years, and people will bring that out. And second, I think we have we will have a smarter data ecosystem as we discussed. So that large language models can help very quickly to coding, to do some scripting, and to create protocols that every different pipelines or models or data sets that they can share the same approach and talk with each other. So I think in the 1 or 2 years, there will be some advanced data ecosystems that give us the capabilities to easily communicate and collect data from different sources. And I think the third one is multimodal AI. I think that will definitely happen to help bridging different formats. So what I mean for multimodal AI is now we talk about text, but you should imagine we have image, we have even voice, right? We have BIM files, we have different formats of the information. So all of this could be gathered together and help to design or generate report or do code verification or to modeling. I think that will of course happen in very quick. Yeah. So these are the major 3 points that I can think of. Not sure any things from Laura your side.
Yeah, Dr. Nora.
Yeah, I am positively hoping that, the hallucination of AI would significantly decreased, 1 or 2 years, or actually we know how to deal with that, right? I'm confident that technology will improve very fast over the next couple of years. On the other hand, it's really AI will never give you the ground truth, right? Human hallucinate too. We make up an answer when we don't know. We call it creativity, but you want to have 100% true from AI. I think that expectation need to be adjusted. That's really where the expert can add value to the process, really how to plug into that process rather than just, expecting AI give you the answer. I think in a couple of years, we'll learn how to work through that process. From the AI perspective, I'm hoping they will design the AI or at least the AI agent for the code compliance should be able to say, I don't know, I'm not sure, if they don't really have the right data to train on. This is really a logistic process to build the trust that I know how to have this AI assistant to work through that process. In the codes community, I have seen emerging interest in permitting, design, code compliance that I think will push us to work together with the software developer and start understanding the problem. I think first of all, I'm hoping in the near term we can come up with some sort of a benchmarking protocol to guide the development. So this way, the AI industry or AI developer will have a clear target. So instead of building a tool first and then hunting for problems, and they know exactly the problem we have now and what is considered acceptable, and they will use that target to build a tool for that process. That's what I think hopefully will happen in a couple of years.
Cool. Okay, one last question. You're just allowed to answer, which one of your 2 options I'm going to give you. So are you optimistic or pessimistic regarding the impact of AI going forward, Dr. Along?
Yeah, I think of course optimistic. Yeah.
All right. And Dr. Nora?
Yeah, me too. Very optimistic.
Optimistic. All right. This is all good. Thank you very much for you too. Everybody, you heard it from the expert. This is the world we're walking into with AI. Millie, back to you. Hope it fit the needs.
It was amazing. I think it was a fascinating topic, and we should do a dedicated webinar at some point in the not too distant future to capture this in a more structured way. I think the ideas that you 3 generated goes along to the work that we are doing in my team. So I'm very excited about that. So I'm going to share my screen for a second, and then we will close. So can you see my screen?
Yep, we can see it.
Okay, so thank you very much to both moderators, the presenters, as well as the panelists. This was a really great symposium that Matt and Rose put together, as well as Meredith. Usually, Meredith is the one who is chairing these sessions, but as you may know, she has a temporary hope assignment, and she will not be participating in the near future. So I'll step in and start continue her work, hopefully. And so I'm thinking, like we have to start thinking a little bit more. And as we move forward, I think it would be a good idea to establish advisory committee. Like, yeah, we need several people to sit there instead of Meredith. So like, I will be approaching some of you to sit on that, with the objective of prioritizing the topics for our working group over the next 2 years, identify champions to lead them, and publish a 2-year plan. In my mind, I think I know what our first webinar is going to be about. But in any case, thank you for the presenters, the moderators, and the panelists, and thank you for making the time to be here. I think, Matt, you are going to be sharing the presentations, and this session is going to be up on the Building Energy Group, Energy Codes Working Group website. So stay tuned. Thank you all. Have a good day.